All right, so let's continue with the example we just talked about last time on Monday. Okay? All right. Let's recall the example we just saw last time. Let's review what the problem is. It's really important to compare these two examples and figure out how the if statement is going to behave differently. That's the plan. All right. If you just came, please settle down. Okay, we already started. All right, let's now consider these two if statements. The first one, if you look at the first one here, we got some numerical condition here, relational operation. We got I larger than or equal to 3, and also I less than or equal to 8. We basically got a single if statements. Okay? Okay, guys, I just cannot continue like this. Okay? If you don't keep quiet at the back. Okay, now, the second fragment we have is like two if statements over here. Basically, the branching condition looked just identical, but we have to know, in this case, they may or may not behave the same. That's something we'd like to discuss. Okay, let me show you this, and I'll switch to the iPad. And the second example we want to compare in a very similar structure. So now we change the branching condition a bit. So now the two branching conditions we have is I less than or equal to 3 and also I larger than or equal to 8. It's actually different. However, it's still a single if statements. And the second example over here is two if statements. Okay, let me switch to the iPad. So that's kind of the two questions I have for you, but we answer them together. Okay. You really have to see, when you are given a similar example like this, you have to be able to judge. Okay, this first one. Basically, let's just consider these conditions over here. The first one there, basically you can see that we got these two conditions, larger than or equal to 3, and also less than or equal to 8. Let's do a similar exercise like how we did in the tutorial video. The first condition we have is I larger than or equal to 3, right? If you think about it, I larger than or equal to 3 is pretty much like this range over here, all the way towards infinity, right? That's what we talk about. The second one over there, I less than or equal to 8, is pretty much like this one here, less than or equal to 8. If you think about these two intervals, you can see apparently these intervals actually overlap. You can see that. Let me just highlight it. So that means if you have any values in between this particular overlapping level, it is going to satisfy both conditions at the same time. Agree? Okay, let's agree on that first. And then we're going to see next how this will affect the behavior for the if statements. So first of all, these two intervals actually overlap with each other. What about the second one? The second one, let's have a look. The second one, basically, if you go back to the slides, the second one is over here. The second one, we still got these two conditions here, less than or equal to 3, and also larger than or equal to 8. If you want to look at that, let's do the similar exercise over here. For the second one, you can see that we got less than or equal to 3, which means something like this. Any value less than or equal to 3. And the second one over there, the green one. That one there, larger than or equal to 8. Something like that. You can see there is no value that is going to satisfy both conditions at the same time, right? Okay, it's really important to see the different nature of these two pairs of conditions. So now the question is, what happened if you put these conditions either overlap or not overlap into if statements? That's where the tricky thing can happen. That's why we want to go over the two examples. So now, I want to go over the first one over here, okay? The first example there, let me just tell you the syntax. It's just a snapshot from the slides. But let's first of all understand one thing here. If you look at this particular one over here, we have if and also else if. This tells me that this is a single if statements. A single if statements. Just a single one. On the other hand, if you look at the second one there, you can see that we have if, without else if, and without the else. We have another if, also without the else if, also without the else. So what does that mean? That means we actually have two if statements. Two if statements. it's very crucial for you to identify how many if statements you have. In the first case, you got only a single one. In the second one, you got two different if statements which are independent of each other. Okay? So now, let's go back to the first condition that we talked about. Because we know there might be a value that goes in, that can satisfy this condition here and this condition here, right? In the case we put this in the context of a single statement, only the first satisfying branch will be executed. However, if we put them into multiple if statements, all the satisfying one will be executed. That's kind of intuition. Let's see exactly. So now let me choose a value over here. So the value I choose is simply just 5. Let's say I choose the value 5. 5 apparently can satisfy this first branch and also the second condition here, right? Let's try 5 altogether. If I choose the value to be 5 here, so now I larger than or equal to 3 will be 5 larger than or equal to 3. That will be true. So that means I'm going to execute this particular branch. And now, because we know it's a single if statement, as soon as we have executed the earliest branch, do we have to care about the rest? We don't, right? So all the rest is simply just bypassed. So from this case, we only have I is larger than or equal to 3. Okay? Now, let's say we have two if statements over here. In that case, we have if, we have if. We have the same condition over here. Now, if we still choose the same value 5, which is going to make both conditions true. So now 5 larger than or equal to 3 is going to give me true. That means I'm going to execute this for sure. And that's the end of the first if statements. And now we're going to start the second if statement over here independently. Okay? And for the second if statement over here, now 5 less than or equal to 8 is going to give me also true. That means I'm also going to execute this statement as well. So that's why I got 2 lines of output over here. So what have we really seen in this particular case? This case really illustrates when you have a single if statement versus multiple if statements. If the branching condition is specified are overlapping, then you might have different behavior at the runtime. That's exactly what I just illustrated. Okay? So now I might give you different values later on to judge your understanding, but all you have to do, whenever you're giving the branching conditions over here, always draw a diagram to see if they overlap with each other or not. If they do, you have to be careful whether we talk about if a single if statements or multiple if statements. Okay? Now let's move on to the second example. The second example can basically go to the other extreme. We still have the difference between a single if statements versus multiple if statements. But now the conditions we are trying to specify for the branching conditions, they simply don't overlap. Okay? So now you can see that over here. You can see this range over here does not overlap with this range. So that's the conditions we're going to try out. Okay? Let's put them into the same structure over here and then try it out. Now you can see we still have this guy over here is just a single if statements. Okay? Just a single one. On the other hand, how many if statements we have? We got 2 if statements. Okay? Again, that's syntactically you have to tell whether you got a single one or the multiple ones. If you got multiple ones, each one of them is independent of each other. Okay, let's try this value here. Basically, I'm going to try out a value because we know there's no value that can actually satisfy both in this case, right? Let's say I choose a value 2. Okay? If I choose 2, how can that be visualized? If I choose 2, that means value 2 is only going to satisfy the blue interval, but not the green one. Okay? Now, let's have a look. But cannot satisfy both. Only either the blue or the green or neither. If I choose 5, it can satisfy neither. Right? So now, let's go back to this code over here. If we try to trace the same structure of code, if I choose I to be 2 in this case, right? Let's say it's 2. So now 2 less than or equal to 3 is going to give me true. That means I'm going to execute this line over here. And because it's a single if statement, as soon as I execute the very first satisfying branch, all the rest will be bypassed, which means this part here, I just don't even bother to execute it. So that is why I got this only one line over here. In the previous example, where the conditions overlap, I have an extra line in the case of the multiple if statements. But do we have the same multiple printout in this case? The answer is no. Simply because the conditions, they simply don't satisfy, they cannot be satisfied at the same time. Let's try to see. Again, let's choose the same value over here. First of all, the value is simply just 2. Okay? And the first condition over here, 2 less than or equal to 3 is going to give me true, right? So after this, the first if statement is done. However, we still have to evaluate the second if statements no matter what, because they're independent of each other. But in this case, when we try to evaluate this particular condition over here, I is 2, 2 larger than or equal to 8 would be false. That means we also bypass them, but for a different reason, okay? You just want to know bypass simply because this condition here evaluate to be false, okay? So we don't execute it, and we also have one line. You can see that in the case of non-overlapping conditions, having a single if statement versus multiple if statement is just going to give you the same behavior. On the other hand, if you have overlapping conditions, it will give you different behavior. Okay, that's about the lesson for this example here. Any questions? So several points over here. Number one, when you are given the branching conditions, you want the judge to see if they overlap or not. Number two, if you are given if statements, you want the judge to see how many if statements you have. Do you have a single one or multiple ones? Okay, so there are two angles over here for you to consider. Okay, do go over this example very quickly. It's quite important. All right. If no questions, I'll move on to the next one, the next point. Okay. So now another very important thing also for your lab test. Okay, I will talk briefly about your lab test in the at the very end of today's lecture. I'll give maybe 1 or 2 minutes for that. Okay, that's about if a single one versus multiple one, which we just went over for the 2 examples. Now, I want to talk about the scope. In the last tutorial video for this week, I did talk about a little bit about scope. I want to give you a little bit more systematic introduction. Because in the lab test, if you want to declare new variables inside the method, you want to make sure you use the variable in a way that is not going to violate the scope rules. Okay, I'm just going to give you some example here and give you intuition. Okay, it's actually quite easy to follow. Let's see. First of all, first example. In the case of lab exercises, you are always programming inside this particular main method, right? In the lab test, you will be given a series of methods, but within each method, the scope rule still applies, the same idea. Okay, let's say within a particular method, this is how you can think about it conceptually. Let me just try to highlight it, okay? Conceptually, you can think about from the beginning until the end, this is kind of the scope. Let me try to draw better. This is kind of the scope for the entire main method. Okay, the blue one. It's just the scope for the whole main method, which means any variable you're trying to declare right under the scope can be used in the current scope or in the subscope. So what do I mean by subscope? Whenever you create a if, whenever you define some if statements inside the if branch or inside the else if branch or inside the else branch, they are called subscopes. But I'm going to illustrate to you. So now, for example, you can see that over here in the blue scope, I declare I over here. That's a variable I declare over here, which means I can be used in the various places. For example, I can definitely use I over here. Okay, you can see I is simply just a line in the main method, right? That's one thing to note. And I can also use I over here. Okay, that's a simple case. So now the complication will come if I introduce a single if statement and also with branches. That's where the complication can come. Let's see that. First of all, let's identify how many if statements do we have in this case. Just one, right? With if and else. Okay, let me just highlight it for you. So basically, you have only a single if statement, whereas this is, so each branch has a different scope. You can think about like this way. What I'm going to draw here in pink is simply just the scope for the if branch. And what I'm going to draw over here for, let's say in green, it's going to be the scope for the else branch. Okay, let's talk about, since it's color, completely color, so it's not easy to talk about scope. The largest scope we have is the blue one, which covers the entire main method. Okay. However, we also have 2 subscopes over here. The pink one, which corresponds to the if branch. We also have the green scope, which corresponds to the else branch. Okay, let's see one example here. For example, inside the pink branch over here, we can, let me just annotate one thing for you. You can think about, let me just get rid of that. So this is a subscope. Okay, Oh, thank you. So I'll try to be a little bit careful. Thank you. Okay, so basically, this is a subscope. Okay. And this is just another subscope. Okay, subscope as well. Each subscope is also independent of each other. Okay, so now let's see over here. In subscope number 1, the pink one, you can see over here we are trying to make use of I over here. Remember what I said before? If you declare I to be at the blue scope, you can definitely use it either in the same blue scope over here, or you can use it in the subscope. In this case, the pink, right? You can also use I over here. This is kind of what I did in the tutorial video you have. We can declare the amount outside the if statement, and we can reassign the amount in the else if branch or the else branch, right? That's all we did in the tutorial video. Okay, so far everything compiled. It's legal use to use I over here in the subscope, whereas I was simply declared in the blue scope outside the pink and outside the green. Okay. Any question about the first example? This code here compiles. It's the legal use. Of course, we also want to learn from the mistake. I'm going to show you something soon that does not compile and see why. But this is something you want to have conceptually, how the scope looks like. Okay, let's go to the second example over here. Okay, the second example here still compiles, but we try to introduce a little bit more things for you. Okay, again, let me just be consistent with the color here. So now we still have this particular scope for the main method over here. Okay, that's scope. And then we also have a scope for the if statements. Okay, that's in pink. We also have a subscope, second subscope, for the else branch. Okay, that's kind of consistent with how we did in the previous slides. Now, one thing that's new. Let me just highlight the one you know already. First of all, you can see that over here, I was declared over here, and I can still be used inside each of the subscope. That's what we know from the previous slides. What can we do more? Within each subscope or within each branch, you can declare new variables. It's absolutely allowed. Okay, for example, you can see that over here. Let me use red over here. You can see we declare just another integer variable j. And over here, for the else branch, we are also declaring another integer variable j. You might be asking, didn't you say before in the elementary programming, you can never redeclare a variable? I said that yes, but in the case of redeclaring a variable with the same name in a different subscope will be allowed. Okay? So now, of course, don't get me wrong. For example, let's say this. Let's say if I have this main method here, let's say after declaring integer I, if I try to declare another line to say integer I, it will not be allowed. Okay? However, over here, integer j versus the integer j over here, they belong to different subscope. It is allowed. One more thing to say. If you look at especially the j over here, the pink one, versus the j over here, they actually mean something different, even though they are both called j. Okay? The j in pink over here is referring to whatever j you declare over here. Okay? Nothing to do with this j here. Nothing to do with it. They are simply independents. Similarly, when I refer to the j in the second subscope, it also just refers to this particular j I just declared. Okay? Let me give you one example. Let's say we try to read in some input from the user. Okay? Let's say we read in, let's say 5. Okay? And then we're going to store 5 into I. And then we know that 5 larger than 0 is going to give me true. That means I'm going to execute just this particular branch for the if, whereas the else branch will just be bypassed. Right? Now, we're going to declare j over here locally as a variable. And then j is going to be I, which is 5. 5 times 3 is going to give me 15. That means j here is going to be 15. Right? 15, and then we can say if this particular j, which is 15, is larger than 10, I can do something else. Right? So j is only referred to this particular j in this particular scope. On the other hand, let me just do one more for completeness. Let me choose another value for you. Let's say I use red. Let's say now this time the user enters, let's say -2, for example, in red. If they enter -2, that means -2 will be stored in I. In that case, if I try to evaluate -2 larger than 0 is going to give me false. In that case, I'm going to bypass the if branch, and then I'm going to execute the else branch. Now for the else branch, I'm going to have declare just another variable j, okay, and the j is going to be I value, which is -2. So -2 multiplied by -3, which will give me 6, right? And then when I say over here, if j is less than 10, so j over here is referring to this particular j I just declared in this particular subscope. And I'm just going to evaluate 6 less than 10, in this case, false. Okay, any question about this? So this slide here is mainly to show you whenever you got if and if branches or branching conditions, they simply declare new subscope. Within a particular subscope, you can declare as many local variables as you like. Yes?
You declare it as sub.
Yes, so my argument goes on and on and on. Basically, within the subscope, you can declare another subscope. Within the subscope, you can declare another one. So how deep should you go into, depending on what you need exactly. Okay? I'll just cover the basics now. If I notice any obvious error you might make in the lab, based on my observation, I will talk about example in the class. But that'll be good enough for now. Okay? Okay, that's the second slide. Let's look at the third one. So now let's introduce some error over here for you. Okay, just really appreciate the scope. Again, let's identify for ourselves what the scopes are. Again, the blue one is entire main method. This is the entire main method over here. Okay, and then we have the pink, which is the if statements over here. Okay, and then we also get the green one, which is the else branch. We got 2 subscopes. Let's see what's going on over here. Okay, now let's go directly to the error. In the else branch, in the green one, in the else branch, we are doing, first of all, we are declaring a new variable called k. That means we can only use k inside the green scope. That's all we can do. However, try to see what we're doing here. Can we use I here? The answer is yes, because I will simply declare the blue scope. That's how many we just covered. Now, when we have another condition over here, now we are trying to use j, and we are trying to use k. Okay, now can we use k? Yes, because k was simply declared in the same scope. Now, can we use j over here? The answer is no, you cannot use it. Why? Let's be very precise here. So now let me highlight. First of all, we have j over here, and j was declared where? In the pink scope over here. You cannot go across the scope for the variable. Okay, so this is illegal. Okay, so j over here is illegal, which means you have some type error. J is declared in a different subscope. So you just cannot do it. Okay? Similarly, let's say in the pink scope over here, if I just add a new line for you, if I say if, for example, k is larger than j. Okay, if I try to do that, that will also be a compile time error, because if you look at the k over here, let's use green over here to be consistent. If you try to refer to k over here, you can see k was declared over here. So that's also illegal for a similar reason. So if you try to refer to k here, it's also illegal. Illegal, k is declared in a different subscope. Okay, for a similar reason. Okay, this slide, the message is clear. Whenever you try to use any variable inside a particular scope, either use the local variable you just declared, or some variable that's declared at the main scope, I mean the main method, or the method you're given. You just cannot use the variable from another scope, subscope. Are we okay? Okay, hopefully you can learn from this example. Let me see one more. How many more? Okay, we got one more, yes. This one, okay, is also interesting. Okay, this one also needs some drawing over here. Now, let's have a look at this. Again, let's identify what we know already. Again, this will be the scope for the main method. Let's put it here first. Actually, let me draw it better. So this is the scope for the main method here. And let's draw the scope for the if statements, the if branch. That's the scope over here. And then we also got another scope for the else branch. Okay, like that. And now let's go directly to the error over here for us. The error really is in this particular line, line number 11. Okay, line number 11. First of all, we are trying to use both I and j. These are the two variables we are trying to use. Okay, I is legal to use. On the other hand, j is illegal to use. Okay, but we're going to see why. Okay, let's see first of all why I is legal to use. Simply because for the same reason. Let me just, you can see I over here. You can see I over here is okay because I will simply just declare in the same blue scope. That's fine. What about j over here? J over here, you can see where was j declared. J was declared in two places. J was declared over here, and j was also declared over here. And these two declarations are okay because they just belong to different independent scopes. However, you can think about intuitively, when you're trying to use the j over here, this is simply not legal. Intuitively in this example here, which j are you referring to? Are you referring to this j or are you referring to this j? It's ambiguous, right? You simply don't know which one. So in general, this is just not good. In a more general rule for you to observe, every variable is declared inside the scope. For example, for j over here, the one I'm trying to highlight in red over here. So this is what j belongs to. You cannot go outside this particular scope. Similarly, if you try to look at the second j over here, it can only be used inside this particular green scope and not outside it. So that's why when you're trying to use j here, neither of them is allowed. Okay? That is why this is also not legal. The last example is a little bit trickier, but we also did an example like that in the tutorial video. Are we clear about this last example? Are we okay? Yes. Can you declare? Yes, you can. Yes. The question was, can we do the following? I'll just write down exactly what you said. Can we say, for example, let's say we have the main method over here. Okay. And then can we say the following? Let's say if something over here, and then we simply declare integer j, and then you can do something about j, and then you're asking if can I do another if statement, right? Yes. If you do another if statement over here, and then here I also say integer j, okay? The answer is yes, you can do that. And similar arguments. Over here, for the first one, this is the scope for this particular j, all right? And this is the scope for this particular j. And they are, again, independent of each other, okay? Yeah, every time if you want to think about scope, think about we're boxing the lines of code about the variables you can use. Okay? Sometimes you might find declaring variables inside a particular subscope being more useful. Sometimes you might find it to declare as a variable just in the top level of the blue scope, the main method will be more convenient. It's really up to you. Okay? Any questions about this? Just about the scope. Of course, the best way to really exercise the scope is try out the examples, right? Okay, that's about the scope. And I want to go on for the slides. Okay, so these are the three examples. I do have some description over there for you for each example. You can also read through them. Okay, but everything has been covered. Okay, so now let's have a look at the next one, especially the 2.3. So this is particularly important. Okay, make sure you don't have such a mistake in your lab test 1. So now I want to talk a little bit about primitive versus compound. It's just a little bit academic term. Primitive simply means simple. Compound simply means complicated or sophisticated. So starting from lab 1, you already have to use nested if statements. It's considered as compound. If you only have a single if statement, whereas for each branch you simply do some simple printout or simple reassignment, it's considered simple. But as soon as you try to nest the if statements, it's considered compound. That's the distinction. Okay, a statement is just a block of code, and then an assignment is just a primitive statements. Okay, that's the simplest one you can have. Now, what about compound? Compound means you want to combine several statements together in a sophisticated way because your program simply need that kind of logic for you to write. Okay? Now, let's look at one example here, and then we'll try to trace the code. Okay, let's look at this code over here. Okay? I'm going to try out different test cases with you. So all you have to know is you have to know how to write them, and you want to know how to trace them, from both directions. Okay? Let me just go over the code structure with you very quickly. Okay? So basically what we have is, in line number 1, we declare a variable called x. You know what? Let's trace the code right away. That might be easier to see. First test, let's say the user simply enter 5. Okay? The user enters 5 from the input. That means x is going to store 5. And then y is just going to be 0. And now x larger than or equal to 0 is going to give me true, right? 5 larger than or equal to 0 is going to give me true. So that means I'm going to bypass the else branch. And then I'm going to execute the first line over here. So I'm going to say x is positive. That's what I'm going to print out. And then what about here? The first if condition here. 5 larger than 10 is going to give me false. So I should really evaluate the second branching condition. Now, 5 less than 10 is going to give me true. So that means I'm going to simply do this particular line of code. I'm simply just going to reassign y to be this particular expression. Okay? That's the execution flow. And then we also bypass the else branch because the else if branch is already executed. Okay? That's the first test. Now let's see the second one. Second one is going to be a slightly different execution path. What about the second one? Let's say x is 10. So that means when we try to read the input from the user, let's say we want to store 10 into x. So now when we try to evaluate, okay, we do second line as well. So now let's say the third line. 10 larger than or equal to 0 is going to give us true. That means we still bypass this particular else branch, right, for the second round. Now what about line number 4? Well, we'll still say x is positive, still the case, but now let's try to execute this second if statement that's nested over here. So now if we try to do that, what about the if branch? 10 larger than 10 is going to give us false, all right? So that means we bypass this guy here. And then what about the else if branch? 10 less than 10, also false, right? That we're also going to bypass this particular one. So we're only going to execute this one here, the else branch, no choice. Okay, so far so good? Now, final one. The final one is going to be, let's say x just minus 2. Okay, we're going to read from the user, and then let's read in minus 2. Okay, line number 2 will still be executed unconditionally. And then minus 2 larger than or equal to 0 is going to be false this time. That means the entire if branch for this particular run is going to be bypassed. And we're going to execute this particular else branch line by line. And then the first line is going to be system out of print line, x is negative. True, because minus 2 is really negative. And then we're going to execute this particular block. And now minus 2 less than minus 5 is false, right? Okay, that means this is false. So that means we don't execute this line here. Right? Make sure you're comfortable with a nested if statement like this. Okay? It's really important, both for you to write and for you to trace. Okay? Both are important. Any questions about this? Yeah, if you find it a little bit too fast, I'm sorry for that, but do watch the recording for this part if you need it. Okay? Right, let's go on to the next one here. Logical operators. So we did talk about logical operators in the tutorial video. I just want to remind you about the table very quickly, and then we'll do examples, right? You really want to get used to the example for logical operators. Okay, just let me go to this particular slide. Let me just show you first on the slides. Okay, logical operator just for you to really combine Boolean expressions together. Okay, and now we got arithmetic operations, and we got, okay, basically something you can read. That's easy. So now we got 3 kinds of logical operators. We got exclamation mark for logical negation. We got ampersand for conjunction. Vertical bar for disjunction, right? Let me remind you about the truth table very quickly. Okay? For disjunction, for negation, it's very easy. If you're given, so P itself can either be true or false. These are the only two possibilities. In the case of P is true, when you say not P, it's going to give you false. And in the case of a P being false, it's going to give you true, right? Just negate the result. That one's easy. So now what about conjunction and disjunction? You don't really have to memorize the whole table. Too many things to memorize. You just got to understand exactly the special circumstances. Now, in the case of the conjunction, this is how I will remember it. The only way, if I say P and Q, the only way to make P and Q true is when both are true. That's the only way to make it true. Other than that, it will all be false. Doesn't matter which one is false. It can be the left one is false. It can be the right one is false. It can be that both are false. Doesn't matter. Okay? As long as it's not the case that both are true, it's going to be false eventually for the conjunction. What about disjunction? For disjunction over here, it's kind of the opposite. You're thinking this way. Disjunction means something or something. The only way to make disjunction over here, P or Q, to be false is when both values are false. That's the only way. Okay? That's how I will remember it. That's the only way. If either one is actually true, doesn't matter which one, it can be both true as well, then the result will just be true. So all these three cases will just be true, which means it can be the right-hand side is true, it can be that the left-hand side is true, or it can be both are true. Right? That's the truth table for all the three operators. I assume you're reasonably comfortable with it. After this, let's do some example. Okay, logical negation. Okay, that's a truth table. Let me just go to example right away and show you. A very typical way to write the logical negation is like this. Okay, let me just give you one example. Let's say this. Let's say we have a program over here. We simply, again, we're going to reading the radius from the user. And then we want to say if the radius is not strictly positive, we're going to print out some error. Otherwise, we're going to print out what the area is by doing radius times pi. Okay, something like that. So now, I want to draw your attention to the Boolean condition we are writing. First of all, we say, let me use yellow to highlight. So we have a Boolean variable is positive, okay? And also, in the branching condition, we say not is positive, which means whatever is positive is either true or false, we're going to negate the result. Okay? Logically speaking, it's going to work, but let's see exactly by some examples. Okay? And how do we determine for is positive? We're going to see over here what radius is. If radius is strictly larger than 0, of course it is positive. Otherwise, it's not positive, right? Let's try out different examples. Okay? The first one, let's say the user enter 0 for the radius. So which means this particular value over here is going to be 0. And then radius is going to store 0 over here. Okay? So that means radius larger than 0, would that be true or false in this case? False, right? So you got 0 larger than 0, so that means it's positive in this case, it's going to be false, which is right because 0 is not positive. Now let's see how the code will be executed. We know that it's positive itself is false. And then applying the exclamation mark is going to be true. That means we're going to execute this particular branch. We're going to say error, the radius must be positive. So this is correct behavior. Okay? That's just one run. Let's see another one. Second run. Let's say we got another negative value. It's going to be a similar way, but let's do it very quickly. Let's say we read in -3. That means radius is going to be -3. Now, -3 larger than 0 is going to be false, right? So it's positive is going to store false. And then we know it's positive is false. Not false is going to give us true. So in a similar way, we are also going to complain error value must be positive, right? So far we got two test values that's going to execute if branch. Let's give another value that is going to go to else branch for completeness. Let's say we got 5 from the user, okay? Let's say the user simply enter 5, and then radius is going to store value 5. And now radius larger than 0, in this case, 5 larger than 0 will give us true. That means it's positive over here is going to store true. unlike the previous two cases, which is false, right? Now, what happens if we try to evaluate the same if statement here? So now it's positive, as we know. In this case, it's going to be true. And applying the logical negation exclamation mark is going to be false. False means we're going to bypass this particular branch, and then we're going to execute the else branch, right? And going to say area is whatever 5 multiplied by 5 multiplied by pi is. Okay? So we have seen 3 different test cases over here. Each one of them will correspond to a different run. Okay? Hopefully that's clear. Okay? You want to be comfortable with logical negation, so this is just one example to show you. Okay? Now, also we do talk about logical negation last time a little bit. Okay? That's about logical negation. Let's do some logical conjunction example, right? Again, it's best to use some example to show you. We already know about this table here, okay? Now, let's talk about this particular fragment of code. What we're gonna read in from the user would be some integer age, okay? And then we simply want to see, so let me highlight the things you should look at. We have Boolean is old enough, which means if the age is larger than or equal to 45. And also, if the age is not too old, that means strictly less than 65, let's say, okay? And then we have these conditions over here. It is not the case, it's old enough, and also it is old enough and it is not too old, and also the else, right? So this is reasonably complicated. But we want to see exactly what values we can plug in so that it's going to execute different branches. That's something we want to do, okay? Let's try that. Test case number 1. Let's say we try the case where age is simply just 30. Okay, that means the user is going to store, we're going to store 30 into the age. Let's try that, okay? Now for that, 30 larger than or equal to 45, false. Not old enough, okay? Is old enough is going to be just false. And now we got 30 less than 65 is going to be true. So it's not old enough, it's not too old over here, it's going to be true. Okay, false and true so far, okay? So now we have to see exactly how these two Boolean variables can be manipulated in the branches. Let's see, okay? What about the if branch over here? When we say not the case is old enough, is that true or false? Given that it's old enough over here, we just computed is false, right? So not false is going to be true. So that means in this particular case, it's going to give us true. So we're going to say it's a case of young. Okay, and then bypass the rest. Okay, let me do one more, and then I can leave the third one for you to as an exercise. Let's say the second one over here, let's say we choose 50, it's more like a middle age, right? So now let's see exactly how we have a different behavior for this particular value. Let's try. Now for this second case over here, the age is going to store 50 after the user enter 50, right? Now what about is old enough? So 50 larger than or equal to 45 is true. So that means it's old enough is going to be true. And then what about 50 less than 65? That's also true. So it's not too old is also true. So now we have true and true for both Boolean variables. So now how do we trace the rest of the code? Let's see. When we try to evaluate the branching condition for the if statement here, is old enough, we know that it is true, right? That's something we just said before. So applying the negation not true is going to be false. So that means this particular part is going to be false. That means we don't execute this particular part. It's not young, okay? And then here, so that means we have to go on to the else if branch to see if it is satisfied. Is old enough? We know that for this particular case it's true. It's not too old, it's also true, right? You remember the two true over here. So true and true is the only case that can make conjunction true. So that means this condition over here is true. So we're gonna execute this particular branch for middle-aged. Okay, as an exercise for you, try 70 and see which branch will be executed. Okay, that's an exercise for you. Finally, let's get to logical disjunction. Oh, that's something we just saw. Okay, so just the last one, I'll leave that as an exercise for you. What about logical disjunction? Again, you have to know the truth table by yourself, which I just mentioned. So let's again see one example for logical disjunction, okay? Just to see how we write the code. So now let's see that. Okay, here. Again, let me highlight the Boolean variables you should really look at. So we got a senior, which is age is larger than or equal to 65, right? Just different example. And also we got is child is considered if your age is strictly less than 18, okay? And then the branching condition we have is either you're a senior person or you're a child, in which case we'll give you some discount for some price, okay? Let's see how this can be traced. So we just use, again, I will use maybe 2 test cases to show you, okay? Let's see the first one. The first one, let's say 70. 70 apparently is a senior person, okay? If we try to store 70 as the age for the user, and now 70 larger than or equal to 65 is going to be true. That means the senior should be true. And 70 less than 18 apparently is false. That means the person is not a child. So true and false. So now, when you say true here and false over here, true or false will give you true, right? It's going to give you true. Overall, it's going to give you true. That means you're going to give the discount for this particular person, okay? What I will leave as an exercise for you, for value 15, that's an exercise for you to see what, exactly which branch you will execute. Well, I'll do one more with you. What about 40? Basically, 40 is neither a child nor a senior person. Okay, let's see. So now let's say we store 40 as the age, let's say. And now it's senior. 40 larger than or equal to 65 is false. That means its senior is going to be false. And 40 less than 18 will also be false, right? So that will also be false. So you got false and false in this case. So now in the case of the if branch, you basically have false or false. This is the only scenario where it's going to be false. That means that part in there is going to give you false. So we bypass this particular discount action over here, right? And we should really go on to the else branch since there's no else if. So you go to the else branch directly. In that case, we're just going to say no discount for this particular person of age 40. Okay, that's just another example for logical operation. Any questions? Okay, let me talk about maybe just 1 or 2 minutes about lab test. Okay, and then we'll finish the lecture for selection maybe next Monday. But let me talk about lab test very quickly. Okay, so now for lab test 1, we got 3 lab tests overall for this semester. Okay, it's going to be next week, January 28th, depending on which your scheduled session is. Make sure you go there in time. We'll start promptly in the beginning. Okay, notice that the way you write Java program is going to be different from how you wrote the program for lab exercises. Let me just verbally summarize. In the lab test 1, you cannot use any scanner input. No input on next line, no input on next in, etc. Also, you cannot use system.out.print line. Okay, these are the 2 things you don't do. Okay, what should you do? So there's a video to show you exactly what you can expect. If you haven't seen the video, I encourage you to see it right away. Otherwise, you're behind. Okay, and this is something I also mentioned since I released the lab test guide. We will be very strict on the way we evaluate your code. What you will be given will be simply 2 Java classes, okay? 1 tester and 1 with a number of methods. What you're given simply has no compilation errors. So that means when you submit your code, we don't expect any compilation error. Namely, you should not miss any semicolon, for example. You should not miss any brackets, things like that, right? So it's now already week 3, so hopefully you're okay with this kind of error. Also, there should be no type errors. For type error, what I'm most worried about is the variable scope, which we just covered. So now it should be okay. If you got any one of these errors which will cause your Eclipse code not to compile, you will just get 0. And this lab test over here is 5% of your course. Okay, so take it seriously. Okay, and the best way for you to prepare is to look at the guide. Okay, we got 1 guide, we got 1 tutorial video, and also we got 2 example tests for you. Try it out. If you got issues, speak to me. All right. See you.